Hello, and welcome to Julia Programming with a Data Scientist. My name is Dr. Randy Davila, and today we will be talking about strings. If you like my explanation and you like my code, please go ahead and give me a like down below or subscribe to my YouTube channel, as I'll be posting a lot of these videos in the coming weeks. Okay, so before we get started, I need to note that we are using the Pluto IDE. This IDE is available through the Julia package manager, where you will add Pluto through the Pluto.jl package. And I will make a video tutorial on how to do this in an upcoming video. Okay, so please stay tuned to my channel so you can go ahead and see that. All right, so strings. Before we get started, we need to talk a moment about characters. So in the English language, letters, numbers, and common punctuation symbols all are examples of characters. And these characters are represented by Julia as the char type and mapped using the ASCII standard mapping. But of course, there are other characters different than the English language characters. For example, there are Greek letters, accented letters, Chinese letters, and even emojis. These characters are also represented by Julia, and the type that they're given is the char type. Just now, they are mapped under the Unicode standard mapping. Now, regardless of the mapping that is chosen, Julia represents both types as the char type, as I mentioned, and are defined using single quotes. Okay, so if we do single quote A like that and press Shift Enter, we see that this is an ASCII formatted Unicode character. Well, we don't know it's a character yet. We just know that we see ASCII and then Unicode. But if we do something like a Greek letter, which we can do single quote backslash, I don't know, epsilon, and then press tab, we see that we get an epsilon, close that in with a single quote, press Shift Enter, and we see that this is a Unicode mapping alone. We can also look at emojis if we want. So there's the syntax here, single quote, I think it's colon, and maybe we want to look at a cow, colon, tab, we get a cow. Close that in with single quotes. And again, this is a Unicode character. Now, it's important, again, I have to emphasize this one more time, especially for those of you that are used to the Python programming language, characters are assigned with single quotes. And we have to give a single character per assignment, so, or calling, I suppose. So for example, if I come over here to A, and I do like A, B, like that, and I press Shift Enter, I get an error. Because the character literal contains multiple characters. We can only have a single character at a time inside of single quotes. Now, if we want to check the type of these character literals, these types that we're looking at, we can call the Julia typo function. And this is going to return the type that Julia represents this object as. In Python, the equivalent code would be the built-in type function. So let me just come up here and grab one of these guys. I'm going to copy it. And let's see what type of returns. Type of, paste, char type. If I grab the cow, copy. Oh. Let's go down here. Type of. Throw that in there. Okay, single quotes, Shift Enter, char type. Okay. And I probably should have done epsilon next. So let's do type of backslash epsilon tab, Shift Enter. All right. So for those of you that are familiar with LaTeX, all the symbols in LaTeX that you know of are available in Julia, which is kind of cool, especially if you're a mathematician like I am. I'm also a data scientist, but my PhD is in mathematics. For example, the union operator, \cup tab, that's the union. And again, we see that this is a char type in Julia. Okay, so next up we have the concatenation operator. So Julia has a concatenation operator on char types, just like many other languages do. But according to the Julia documentation, and I think I copy and pasted this directly from Julia documentation, and I'll go ahead and read it now. It is not the traditional plus operator used in other languages. And why? Well, Julia describes here. In mathematics, plus usually denotes a commutative operation where the order of operands does matter. This is something that if you're a math major, you took advanced math courses, a course like abstract algebra or modern algebra, you would learn about these operators. So commutative means, for example, well, if it doesn't matter, the order in which you apply the operator doesn't matter. So for matrices of the same shape, A plus B is equal to B plus A. So order does not matter. In contrast, the star operator typically denotes non-commutative operations, where the order of operands does matter. An example with matrices would be matrix multiplication. So if the asterisk means multiplication and A and B are matrices, A times B does not necessarily equal B times A. This is the same thing for concatenating words, right? Greet times whom does not equal whom times greet. So the order in which you pass the variables in to the operation does matter. So in a sense, using the star operator to concatenate or to join characters makes sense because a character, character one then character two is different than character two than character one. Okay, so as a mathematician, Julia does know how to flirt with me. So if we were going to concatenate two characters, we pass the asterisk between them. In Python, as with many languages, the concatenation operator is plus. So let's look at how this works. All right, so maybe let's say, so single quotes, A concatenate with B. And this is what we output. But notice now that there's double quotes here, right? So let's look at the type of this thing. So type of A times B. It's a string, right? And we can keep on applying this operator. So C, you don't have to put white spaces. I just like to in my documentation here. So let's keep on doing this. Let's say times D string. So notice now that we have a bunch of characters that are now been joined together with this concatenation operator. And the order matters, right? Like I see right here, I have A, B, C, D, but if I put a C here and a B here, it's different. So when the order matters and you have single types being listed out, what you essentially have is a sequence. And that's precisely how we're going to define strings. Strings are sequences of characters, okay? And are defined by using the double quotes. So for example, if I do A, B, C, D, like that, and I do type of it's a string. Now notice if I replace these double quotes with single quotes, I get an error. Character literal contains multiple characters. So it's really important that when you're transitioning from a language like Python to Julia, that you remember that there is a distinction. Strings are only double quotes That's the only way you can define them. Characters are only single quotes. And for example, this, it might look like a character, but because it's surrounded by double quotes, it will be a string still, okay? And we can verify that there are these differences using the standard Boolean comparison operator double equals. So for example, if I do character A double equals character A, shift enter, it's true. But if I do character A double equals string A with double quotes, false. Okay. So now that we understand the differences between characters and strings, and also understand that strings are indeed sequences of characters, we can now focus our attention on strings. So when considering strings, there is a nice function inside of Julia for string concatenation without the use of an operator, and it's the function string. So suppose we want to concatenate hello and world, we can do string hello, comma, world, shift enter, and then we get the concatenated string there. Probably should clear this out. Make a little error there. But this hello world here is a little annoying. There's not a space there, and I kind of want to put an exclamation mark. So we can do that using this string function. String, let's pass in hello. Let's put in a white space like that. And then world and put a exclamation mark. Hello world. So we should probably take a moment to focus in on this white space here and look at its type. White space. So if you have a white space surrounded by double quotes, it's a string. And if you do a white space separated by single quotes, it's a char. So we have to remember that in a string, so this is a string, it's a sequence of characters. Each entry is a character, including that white space right there. So it's important to remember that white spaces are indeed characters. Next up, variables. So many times we would like to use a specific string over and over again. And one way to do that is by assigning a variable name to that string and then using the variable over and over again in our program. Now, this notion of a variable is probably one of the most important concepts in programming. And it's kind of a subset of another concept where you want to reduce repetition when programming. So if you're repeating something over and over again, you're probably not programming right. So if you're using the same string over and over again and having to type out that whole string and not treating it in the abstract, you're probably not doing it right. You probably need to assign a variable. So variables are just assignments to values and they have names. And the variable names that you choose are really important. They can be as long or as short as you like and must start with either lower or uppercase letters. They cannot start with numbers, okay? However, when you're defining variables, it's convention and should be followed that you define your variables with lowercase letters. Also, when your variables contain multiple names, it's convention that you separate these names with the underscore characters. So let's go ahead and look at a few examples. I don't know why that's there. Okay, so let's look at maybe first name equals to John. Shift enter. And now we see that we've assigned this variable name to this string. And it's descriptive. First underscore name. Maybe let's do last name now. Doe. Shift enter. And now we have another variable called last name. Maybe we can do full name. And Instead of typing out John Doe, maybe we can just use concatenation and do something like first name, concatenation operator. Let's put a space in there. Concatenation operator, last name. Oh, and we see that we have our full name. And then maybe let's make a university name. I'll say Rice University. Rice University is where I received my master's degree. I currently teach at Rice University. And when I was in grad school there, that's where I first learned about Julia back in 2013. So I've known about Julia a very long time, and I have always been a fan. Shift enter. Okay. So now that the variables have been assigned, first name, last name, full name, university name, we can reference them later on in code. So for example, if I type first name now, shift enter, I see that it's John. If I type last name, shift enter, see it's Doe, full name, shift enter, John Doe, and then university name, shift enter, Rice University. Okay, so throughout the rest of this notebook now, we can reference these variables. One interesting aspect about working with Pluto notebooks, I have to mention though, is that unlike Jupyter notebooks, Pluto notebooks are reactive. So if I change the value of one of these variables, it's going to appear everywhere in the notebook. So for example, if I come up here, so here's the output of first name. First name is currently assigned John. If I change this to Jane and I run shift enter, first name is Jane, and now we see that Jane appears down here. It was John, right? And if I change it back to John, shift enter, it appears down there. So when working in Pluto notebooks, you have to get used to this. It's something I'm currently getting used to. I've only started programming using Pluto notebooks in the past 4 days. It's a little bit different, but I'm starting to like it. So just please keep that in mind. Okay, so now that we have these variables and we know how to concatenate things, it can be the case that sometimes concatenation is a little bit cumbersome. When you're calling this operator a bunch of times, or you're calling the string function, it can be cumbersome. And because of this, we have this notion of interpolation inside of Julia. And basically it works by converting variables into string literals using the $ operator. So if this is a string and I have a superstring I want to contain them in, I can just pass them in after the $. I like to put parentheses. You don't have to. And then this will return a string. Okay. This is equivalent in Python to what's called an F string with Python versions 3.6 and higher. So F string with curly braces is similar to a string in Julia with money signs and open parentheses. So let's kind of see how this works. Let's make a string and do something like first name colon and then money sign and pass in the variable first underscore name, comma. Then we're going to do last name colon money sign, put inside the open parentheses, last name, close off that string. Everything looks nice. Let's see what happens. First name John, last name Doe. Nice. So this is why I added this little line here. String interpolation can be especially useful when you want to show descriptions of the variable. So what is this variable representing? It's representing the first name. So before that, I just pass into the string there, and then I convert the variable back into a string and show it to the user. All right, next up, string repetition. So oftentimes you would like to repeat a certain string over and over again. For example, like if you're making dashed lines, or if you just want to repeat a an urgency warning to the user. And Julia provides two different ways of doing this. So if you have a variable that's assigned to a string value called string example, you can pass that into the repeat function and repeat it k times. So k is just a number 1 to whatever. Or you can take that variable and then raise it to the power of k, and it will appear k times. This is equivalent in Python to just taking your variable and multiplying it times k. So let's see what happens when we do this. So let's maybe repeat first name 4 times. Or if we wanted to make a nice dash line, we could do dash line to the power 10. And we get this dash line repeating 10 times. So that's kind of cool. And I like these string functions. They're really nifty when you're designing output of a given program to look nice in the terminal. So that's why I like these repeating functions. Okay, so in many instances, we're going to also be concerned about determining if a character is contained in a string or if a string contains a subsequence of characters. So let's start by just examining how we would determine if the character C is contained in this variable. Well, it's easy. We just say, is the character an element of string example? So this is the epsilon operator. You can think of it from set theory, if you've ever taken like a discrete mathematics course or something like that. And to access that epsilon, you type \epsilon and then hit tab. So this is equivalent in Python to asking if that character is in the variable. So let's go ahead and see, like, is a, so the character a, \n, press tab, the string Julia. True. Is the character C, \n, press tab, the string Julia. False. All right, so it's that simple. And as a mathematician, again, I love this notation. It's set notation, and it screams to me. Okay, so in a more general example, we would like to know if there's a substring, right? So rather than containing a single character, we would sometimes like to know if a sequence of characters or a string is contained inside of another string. So if this is a variable that's assigned to a string, we can do a Boolean check to determine if this sequence of characters appears in there by calling this contains function. In Python, this is equivalent to saying, does this string, is it in this variable? So, so let's say contains. So an example would be Julia is awesome and I'm learning, something like that. And then does this contain the string awesome? True. Does it contain the string Python? False. Does it contain the string lowercase Julia? False. Again, I didn't mention this earlier and I probably should have. Strings, the capitalization does matter. Okay, so now that we know how to determine if a given string contains a substring, in a very similar fashion, we can ask whether or not a string exists in an example. So it's kind of like the reverse, and it's by the occurs in. So let's go ahead and call this function. So occurs in. So does the string Julia occur in Julia is awesome and I'm learning it? True. But if I do capital THON, shift enter, false. Now, this is in general just searching for substrings, but if we want to know, for example, and this does happen, whether or not a substring occurs at the beginning or the end of an example, we have two functions that can help us with this. If we want to know if this occurs at the beginning of this string variable, we can call the starts with function. If we want to know if this substring appears at the end of this string variable, we call ends with. In Python, these are equivalent to the methods starts with and ends with. And this is something that will appear often when you're learning Julia. At least I've been noticing it, that many of the function calls in Julia have equivalent methods in Python. So it's actually not that big of a deal to transition from Python to Julia if that's what you're doing. So let's say starts with, let's do this Boolean check. Julia is an awesome language. Does that start with Julia? True. If I just copy that, paste, and then do ends with, false. But if I type, does it end with an E? True. So these are really like useful functions, especially when you're dealing with a lot of text data that you might have read in from some text file. So next up, we have indexing. So as I've mentioned before, Julia treats strings as sequences of characters. Okay, so if you have a sequence of characters, you have some finite sequence of characters, meaning that there is a number of characters in your string. This is called the length of the string or length of the sequence. So if this is your example string, how many characters are in here? Well, if we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, oh, 12 with the white space. I almost forgot the white space. We have to remember white spaces are characters. So Julia has a built-in function that can tell us this. It's called the length function. And this is akin to in Python calling the len function. Okay, so if we just say, so length, and then let's put in hello world, then exclamation mark, 12. There are 12 characters. Now, because I'm learning with you guys, I wouldn't take this as like complete fact, but it's my assumption that pretty much anytime you can find the length of something in Julia, i.e. that the thing is expressed as a sequence of elements or types, then each of the elements in that sequence have a location, right? Like this is located here, this is located here, so forth and so on. So we should be able to access those. And this will be called indexing. Now, the locations of characters or elements in a sequence in Julia start with position or location 1. Now, this is unlike most other programming languages, okay? So if we have our example string and we want to look at the first location, this is how we, not first location, we want to look at the first character, this is how we would find it, by passing into these square brackets 1. If we wanted the last character, we would pass in end. If we wanted the kth character, we'd pass in k. Now, this is different than most languages, in particular Python. So if we wanted the first character in Python, we would pass in 0. If we'd want the last character, we'd pass in a -1. If we'd want the kth character, then it would be the same. We'd pass in k. So let's go ahead and define a variable and then play around with it. So example string variable equals to Julia is awesome, exclamation point. Shift enter. So we've assigned that variable. So let's look at the first character. It should be that J right there. So example string 1. Oh, whoa, I don't know what happened there. Example string 1, shift enter, J. Good. And it is that character. Nice. Let's look at the end. Example string end, shift enter, the bang symbol, exclamation mark. And then maybe let's look at the fourth character. So let's count. 1, 2, 3, 4. So it should be the I. Why is it doing that? That is really annoying. Shift enter. It's the I. All right. So we know how to index now. So whenever a Julia type allows indexing, again, this is my experience so far. This might change as I keep on learning Julia. It's almost certain that this type allows slicing. But before we talk about slicing, we have to talk a Julia-specific type that I came across when I was writing this notebook. The unit range and step range types. Okay, so these have representation in Julia that's different than I've seen in other languages. So here A and B are integers, and this is a colon. And what this represents is the integer list starting at A and ending at B, separated by 1. We also have the step range type here, where we start at A, we end at B if possible, and we have spaces of length k. So these are integers, so A plus k, A plus 2k, to the nearest integer to q, less than or equal to q, that here, q is equal to A plus ck. It's the nearest q to B. So I think the best way to understand these is to play with them, right? This is the case with most things in programming. However, to actually view what they are, we need to call these Julia functions called collect. And hopefully with the following cells, this will make sense. So let's do 1 to 15. Shift enter. And notice that this is what appears. Julia has this as a specific type in its language natively. It's really interesting to me. So if we do type of 1 to 15, shift enter, we see that it's the unit range type. If we want to view it, we have to call collect in 1 to 15. Oh, and those are all the integers between 1 and 15. If we want to include a step size, maybe size 3, let's check the type of it. And then let's go ahead and collect that business. All right, so we see that we have 1 plus 3, 4 plus 3, 7 plus 3, 10 plus 3, and then we stop here because 13 plus 3 is larger than 15. So this is the largest integer less than or equal to 15 that is can be reached by adding multiples of 3. Okay, so hopefully you understand the unit range and step range types now, and we can now explore string slicing. So given a string variable, call it string example, we might want to view all characters starting at a given index and ending at a given index. So maybe starting at A and ending at B. Well, how can we easily access these integer indices? Well, we can slice into the string variable starting from A to B using the unit range function. So if we want, so these are possible indices. Right? So maybe if we wanted to start at 1 and end at 15, or maybe we wanted to start at 10 and end at 15, this unit range function gives us an easy way to access the integer indices that we might want to look at. And also, it's important to note that we're going to 15, and this is inclusive, right? We're including that 15. Okay, so this syntax here will access each character in this string variable with these indices, inclusive with B. This is important to remember, different than Python, because when you do this with Python, it's non-inclusive, and you would have to add in 1. Okay, so let's look at what happens. So do we still have string example? No, we didn't define it earlier, did we? I'll just make a new string. I'll say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. All right, so I've assigned this variable to this value, and let's slice it. Say we want to look at indices between 2, 3, 4, 5, and 6. So these indices here, 2 through 6. So string example, and then say 2 through 6. Exactly. Now suppose we want to start at the beginning and end at the end and look at spaces of 2. So let's see what happens if we pass in the step range. So string example, and then maybe do 1 step size of 2 to the end. A, C, E, so does this make sense? A is at index 1 plus 2 plus 2 plus 2. Exactly right. Okay, awesome. We've got it. So we know how to slice strings, and this is really important for later because we're also going to learn how to slice arrays and all sorts of different things. So slicing is a really important concept. In the following videos that I'll make, we're going to revisit it many times. All right, next up, strings are immutable, meaning that string types are unchangeable. They're like a statement of fact or a source of truth. I forget where I might have found this, but somewhere online. You can't modify strings. The best that you can do in Julia is call a function to return a string that takes as input the original string and returns some different variation of it. Okay, so for example, string replacement. I have a typo right here. Quickly fix that. So here I see, say old. So where is it? Say old. Right there. Hide that markdown. All right, so suppose we, with this string variable contains a substring called old, and we want to replace it with a new string called new. Well, Julia has a built-in function called replace. We pass in first the variable, and then inside of that variable, we're replacing old with this new, and we have equals arrow to do that. Python equivalence is the dot replace method. So let's look at an example. So replace John Doe. That's my string, and let's do John will be replaced by Jane. Shift enter, Jane Doe. Okay. Now this is a really useful function when dealing with textual data or string data that you've read in from some text file. Or if you're dealing with like a data frame that was given to you from someone and the columns of the data frames have spaces in them, you kind of want to avoid spaces and maybe you want to replace the spaces with underscores. So like, for example, you have like column name variable equal to sepal length spaces like that. And then we could just call the replace function to get rid of the white spaces. So column name, and we want to replace white space by underscores. All right, so it started off like this, and then we could return this new column name there. Okay. And because, so column name has not been changed. Again, strings are immutable. So if I look at column name right here, it's still a sepal length. But if I did this, column name equals that, this, so it starts off assigned to this string value. And then with this cell here, it will be assigned to this one. So I run that. Oh, I get multiple definitions. I'd have to get rid of this one, actually. Delete that cell. Actually, I would have to do something like this. It would be, what was it? Column name. And we'd fix it like that. Or some combination of these things. And there'll be another video when I talk about best practices when dealing with these types of data that you read in. All right. So we're almost done. In the last few examples, we're going to look at some other modifications such as uppercase, lowercase, and title case. So sometimes you'll have a string that you would like to make a certain format. And for example, maybe you want each character to be uppercase, maybe you want each character to be lowercase, maybe you want each character to be in a title case format. In Python, these are equivalent to the methods uppercase, lowercase, and title. So column name looks like that. So I could say, for example, uppercase column name. So everything's capitalized. I could do lower case, maybe my name. Everything should be in lowercase. And then maybe caps lock. Title case. I love Julia. We see that it's now in the title case format. So that's pretty cool, and could possibly be very useful in some instances. All right, so finally, we need to look at some functions for removing trailing characters and new line characters. So oftentimes when you're reading from .text files, you'll read in the data and then open it up inside of your program, whatever you're using, and see that there's these characters at the end of each entry that you don't want. For example, maybe you have like periods or dashes or new line characters. So Julia provides two functions to get rid of these. The first one is chop. So this will chop the last character off your string, and chomp will get rid of the new line character. In Python, this is equivalent to calling the string from the first entry to the end, non-inclusive, and also to the strip method. So if we do chop of hello, like that, we'll see that that dash is gone. And if we do chomp hello world, and there is a new line character in there like that, new line is gone. Okay. And I should just say, there is so much more. I covered what I thought would be important for those that are transitioning from Python to Julia or those that are starting out in Julia, but there are so many things you can do with strings. And in later videos in this YouTube playlist that I'm making, Julia programming with a data scientist, I'm going to try to cover everything, but I think that this is a good stopping place. Thank you for watching. If you've enjoyed this, please give it a like. If you like what I'm doing, please subscribe to my channel. And I look forward to making more videos for you guys. Thank you.